بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة الاستاتيكا. طبعا احنا عارفين أهمية مادة الاستاتيكا في حياتنا، ده علم السكون، وعلم الاستاتيكا هو فرع من مادة الميكانيكا، على أساس أن الميكانيكا بتنقسم إلى علم الاستاتيك وعلم الديناميك أو علم السكون وعلم الحركة. درس اليوم بيتكلم على الاتزان، والاتزان ده مهم جدا جدا في حياتنا اليومية. ممكن تلاقي جسم كبير جدا صلب موجود على حافة النيل ولكن هو لم يسقط. طبعا تتعجب، دي إرادة ربنا قبل كل شيء، ولكن لكل شيء سبب. ايه سبب ان الجسم ده ساكن على حافة النيل؟ ان مجموعة القوى المؤثرة على الجسم دي تتلاشى، ومجموع العزوم اللي بتأثر على الجسم ايضا تتلاشى. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in static subject. Its title Equilibrium of Collinear Parallel Forces. My dear student, look at introduction about equilibrium, about system of parallel forces. My dear student, look at the rule. What is the condition of equilibrium, my dear student? The condition of equilibrium of parallel collinear forces of a rigid body is an equilibrium, the action of a system of parallel forces, then number 1, the sum of algebraic measure of these forces with respect to unit vector parallel to these forces is equals to 0. Sum of algebraic measure to these forces equal to 0 with respect unit vector parallel to these forces. This is number 1. Number 2, the sum of algebraic measure of moments of these forces about any point in its plane also equal to 0. My dear student, the first condition means that the result of these forces vanishes and then the body will move translative motion. The second condition, my dear student, means that these forces will not rotate the body. As we know before moves, in this case of concurrent forces at a point. My dear student, take care. What is the meaning of the second condition? Moment equals 0 means that these forces will not rotate the body. As we know before moves, in this case of concurrent forces at a point. The first condition only is enough to make that in this case of concurrent forces at a point, while in the case of the forces which are not meeting at a point. Then, my dear student, this requires the second condition also to be sure that there is no rotational motion. My dear student, now we are translate to the first example. A uniform rod of weight 5 kilogram weight. My dear student, what is the meaning of uniform rod? Excellent student, its weight acts on midpoint of a rod. If a rod is 100 centimeter, then its weight midpoint or at 50 centimeter from one of end. Now we are return a uniform rod of weight 5 kilogram weight rests horizontally of two supports at this end, which distance between the two support is 50 centimeter. A mass 12 kilogram is suspended at a distance 30 centimeter from one of its end. What is the required? Find the magnitude of the pressure each of the two supports. Look at the solution. My dear student, look at AB is a rod. The rod is in equilibrium, the action of 4 coplanar forces, which are R1 reaction of support A, R2 action of support at B, the weight of the rod 5 kg at C, at midpoint of AB also, weight suspended at D of magnitude 12 kg weight. My dear student, we know that in equilibrium R1 plus R2 equals 5 plus 12 or equals 17, where AD equal 30 centimeter. My dear student, due to algebraic measure zeros equals 0, then the sum of algebraic measure of forces equals 0. Also, R1 plus R2 minus 5 minus 12 equals 0, or R1 plus R2 equals 17. Sum of algebraic measure of moments of these forces about A equals 0. Therefore, my dear student, 12 times AD plus 5 times AC minus R2 times AB equals 0. Why R2 equal negative? Excellent student. Because direction of moment of R2 about A is clockwise with negative sign. But we have two weights 5, 12, rotate about point A anti-clockwise, its sign are positive. Then, my dear student, find the value of R2. R2 equal 560 over 80 or equal 7 kg with reaction of support of B, which equals the pressure of support at B. Then, my dear student, substitution in equation 1 to find R1 equals 17 minus 7 equal 10 kg weight, which equals the pressure of support at A. My dear student, look at important remark. We can obtain R1 and R2 by finding the sum of algebraic measure of moment 1 about A to get R2. As we did before, and another by finding the sum of algebraic measure of the moment of the forces about B to obtain R1. Then we get the sum of algebraic of moment of the forces about B equals R1 times 80, negative 12 times 50, negative 5 times 40 equals 0. Find the value of R1 by the same method. R1 800 over 80 equal 10 kg weight. After that, we can substitution about equation 1 to find the value of R2 equal 7. We know that R1 plus R2 must be equal 17. Why? Because we have two weight of uniform rod 5, another weight 12, then R1 plus R2 must be equal 17. If R1 equal 10, then R2 equal 7. Another example. My dear student, AB is uniform rod of length 100 centimeter and weight 40 Newton. Acting as a midpoint, uniform rod rests in horizontal position of two supports, one of them at the end A and the other at point of the rod 200 centimeter distance from point B. Weight of magnitude 12 Newton suspended from a point on the rod at 15 centimeter from B. What is the required? Determine the pressure of each support. Also find the magnitude of weight which must be suspended from B such that the rod is about to turn or rotate. Look at solution. My dear student, we have AB is a rod, uniform rod. Look at, we have the first condition, R1 plus R2 equal 40 plus 12 equal 52. After that, this equation number 1. Moment about A equals 0. Find the moment about A to find the value of R2. My dear student, if we find R1, must we take moment about what? X and student about C. To remove R2 and find R1. My dear student, we have two methods. The first method, if we find the value of R1, we must take moment about C to remove R2. If the required R2, we take the moment about A to remove R1. We have two conditions. The first, R1 plus R2 equals 52. This is equation number 1. Then the moment about A, my dear student, 40 times 50 plus 12 times 85 minus R2 times 80 equals 0. My dear student, this moment about A equals 0. What is the forces? We have three forces, 40, 12, and R2. 40 and 12 in the same side rotate anti-clockwise, its sign is positive. But R2 rotate about A in clockwise, its sign is negative. Therefore, my dear student, find the value of R2, 37 and 3/4 Newton. After that, by substitution, about R1 plus R2 equal 52. Therefore, R1 14 and quarter Newton. My dear student, the rod is about to rotate about C. What you deduce? R1 equals 0. Why? Because this supported about A is vanished. Vanishes means R1 equals 0. Then moment about C equals W is unknown times 20 plus 12 times 5 minus 40 times 30 equals 0. Then the W equal 57 Newton. Now, my dear student, we are translate to another example. AB is a rod of length 120 centimeter and weight 600 gram weight. Act at its midpoint. Is suspended horizontally by two vertical strings at point C and D on the rod, such as AC equals 25 centimeter and BD 35 centimeter. A weight of magnitude W gram weight is suspended at this point H on the rod where AH equals 30 centimeter. If the tension in the string at C is twice the tension in the string at D, find the value of unknown weight or W. My dear student, look at the solution. My dear student, in problems about equilibrium, we have two conditions. The first conditions, the forces or parallel forces up equals parallel forces down. In equilibrium, if we have two reaction or two supports, then we have R1 and R2. And if we have two weights downward, must be R1 plus R2 equals sum of two weights. After that, we need the other equation to solve two unknown R1 plus R2. Then we use moment about any point to find the value of each R1 or R2. My dear student, in equilibrium, we use two conditions. Look at the solution of the important example. Look at, my dear student, we have AB, this uniform rod. This uniform rod, its weight 600 grams, act on midpoint at point N. We have two support at C and D, such as the support at C twice support at D. Reaction of D is T. Strength at D is T. Then the strength at C twice the first equals 2T. And we have, my dear student, weight at a distance 30 centimeters from A. Remember, my dear student, strength from C at distance 25 from A, distance or strength at D at a distance 35 from B. My dear student, look at the two equations. Moment about H equals 0 to find the value of T plus 2T. This equation very important. When find the moment at H, we remove the value of W. The required, the tension of two strings, the first T, the second 2T. Too easy to find the value of the tension T. Therefore, 2T times 5 plus 600 times 30 minus T times 55 equals what? Equals 0. Therefore, my dear student, the tension of string 400 gram weight. We know that, my dear student, in an equilibrium, 2T plus T equals W plus 600. Find the value of T, the previous proof, then 3T minus 600 equal W by substitution about T, then W equals 1200 minus 600 equals what? 600 gram weight. My dear student, now we are translate to another example. AB is uniform rod of length 100 centimeter and weight is 120 Newton, acts at point. It rests horizontally of two supports. One of them is a point 30 centimeter distant from A and the second at distance 10 centimeter from B. Find magnitude of reaction of each support. Then find the magnitude of the weight that should be suspended at B so that the pressure of two supports to B are equal. Look at the solution. My dear student, look at AB is uniform rod. Its weight 120. Look at, my dear student, the length of AB is 100 centimeter. The weight of AB at midpoint of AB is 50 centimeter from A, also 50 centimeter from B. We have two support at C and D. At C, at a distance 30 centimeter from A. Its reaction R1. Action of the support at point C. other support at point D at a distance 10 centimeter from B is R2. Then if we have weight at point B, find the value of W. My dear student, we have two equations to find the value of W and R1, R2. We start from moment about B to find the value of R1 and R2. Remember, my dear student, the two supports at C and D are equal from the given. Look at, my dear student, R1 plus R2 equals 120. Find the value of R1 by taking the moment about D. 2 removes R2. Therefore, my dear student, 120 times 40 centimeter minus R times 60 equals 0. Then it's easy to find the value of R1 equals 80 Newton. We know that R1 plus R2 equals 120. Therefore, my dear student, what about R2? Student equal 40. Then R2 equal 40 Newton. What is the value of the weight at point B? When W suspended, let R1 equals R2, each one equals R. Moment about B equals 0. Therefore, negative R times 10, negative R times 70 plus 120 times 50 equals 0. Then R equals 75 Newton. Therefore, my dear student, by substitution, R plus R equals 120 plus W. Therefore, 2R equals 120 plus W. R equals 75. Then 150 equals 120 plus W. Therefore, the weight is 30 Newton in the second required. Then, my dear student, we know that the W equals 30 Newton. My dear student, then we have important example. AB is uniform rod. We have two supports at point C and point D. What is the reaction of first support and second support R1 and R2? We know that, my dear student, the weight of uniform rod is 120. Then R1 plus R2 must be equals 120. The first, we find the value of R1 by taking student moment about D. Another student maybe take moment about C to value R2. This is correct answer also. Then, my dear student, if we have two supports are equal, support at C equal support at D, then each one is 75 by taking moment about C. If we have another weight suspended at point B, the value of the W must be taken by two equations. What is the two equations? R1 plus R2 equals 120 plus W. Then we know that, my dear student, R1 plus R2, each one equals R. The value of each equals 75. Therefore, R1 plus R2 equals 150. In equilibrium, my dear student, the forces up equal forces down, or sum of forces are function or equal 0. Then R1 plus R2 must be equals 120 plus W. What is the value of R1 plus R2? 150. Why? Because R1 equals R2 and each one equals 75. Then the W equals what? 150 minus 120 must be equal 30 Newton. Then, my dear student, this example very important to value unknown of string at C or at D, unknown W if the W or the weight of another body suspended at point B. We use two equations in equilibrium. The first equation, the forces up equal forces down, or some forces equal 0. After that, we use the moment about C to find the value of R2. Other one take moment about D to find the value of R1. Then, in equilibrium unit, we have equilibrium, two forces, three forces, more forces, parallel forces about a rigid body or a uniform. Then this very important lesson to solve many problems about this lesson. My dear student, by the end of the lesson, we know that this lesson is very important to find the value of string or any reaction of any support about the rod. The mini equation, my dear student, must be know that AB is uniform rod, the weight at its midpoint, and to find the value of unknown, we use two equations. The first equation, forces up equal forces down, or sum of forces equal 0, and take moment about each point to find the value of unknown. After that, by substitution, to find the other unknown. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.